Well, hello. I am just looking at my AM FM radio. And as you can see, I can change the volume. I don't know if you can hear it or not, but I'm going to change the volume. Okay. Now this is a very old, there we go. This is a very, very old transistor. Well, it's not that old. It's a transistor radio. And as you can see, it's really up to date because it's got, I can change from FM to AM, and it's got actually a place to put earbuds. Okay. There's no date on here. So yeah, it's kind of old. But I tell you what, this relates to the sine and cosine curves that we're doing right now. Let me turn this, whoops. I'm going to turn this off. There we go. FM and AM stand for something that's related to our sine and cosine curves. AM stands for amplitude modulation. That means, sound waves look like the sine and cosine curves that we've been doing. Amplitude modulation means that the amplitude changes. Okay, so the amplitude is either higher or lower. AM stands for amplitude modulation. This refers to the fact that AM radio waves change in height. Okay, maybe not as high. The radio waves associated with AM radio stations travel parallel to the Earth and then move up towards the sky. Kind of cool. Okay, now FM on the dial, FM up here stands for frequency modulation. Okay, frequency, you know what frequency means, how often something occurs. So when we're looking at frequency modulation, we're looking at a curve that goes like that, where the frequency changes. It might even be super smashed together, like an accordion. Okay, frequency, FM stands for frequency modulation, which refers to the changes in frequency or distance between the radio waves, responsible for, that should be for, the sounds heard on FM radio stations. So what we're going to be doing, and that's why we have antennas on these old things. The antenna gives you more height to pick up those radio waves that are traveling through the atmosphere, okay, traveling through the air. So that's why we have the antenna, to pick up those radio waves, whether you're in FM or AM. I'm going to attach this Word document because it's really cool. It explains the difference between AM and FM channels. I won't take time now to read through it, but I am going to attach it to Google Classroom so you can read through it. It's really kind of cool. I think it's kind of interesting. If anybody's interested in this sort of thing, you can go into this sort of thing in college. It's really kind of cool. Okay, now, what does this have to do with what we're going to do today? There's some crackling there. Okay. All right, and this paper explains why you get crackling and things like that. And also keep in mind, I'm recording right now, so my cell phone is on. So I've got a cell phone signal interrupting radio signals. So this is really cool. It explains why those things are happening. Okay, I'm going to put my radio away now. And I'm going to talk about these sound waves, which are like cosine and sine waves. Okay, let's just first recall. Today we're going to do levels 3 and 4. Last week we did levels 1 and 2. Today we're going to do levels 3 and 4. Let me focus this here. Okay, but first let's recall what the regular sine function looks like. If it's just y equals sine x, it looks like this. It starts at 0 and it ends at 2 pi along the x-axis. This along here, this stands for radians. So it takes 2 pi radians, which is 360 degrees, for the sine value to cycle through all of the values. So it gets to a max of 1, comes back, goes to a min of -1, and comes back. Okay, that's your basic sine curve. The amplitude of this thing is 1. Remember that this is the amp. The amplitude is 1. Well, let's talk about why. Here's your midline right here. Your midline is the x-axis. So your midline is 1, or I'm sorry, your midline is 0. This is your midline at 0. Your amp, remember, is half the distance. In other words, it's really the distance from the midline to the max or the midline to the min. So our amp right here is 1. Remember, it's half the distance of the range. So we have an amp of 1, a midline of 0, and then this one right here, remember, is the number of cycles from 0 to 2 pi. And for your basic sine curve, it's 1 cycle from 0 to 2 pi, because it takes 360 degrees to go through all of the values. Okay, so basically, this is why this just reduces to y equals 1. So I don't have to write the 1. 1 sine 1x plus 0. So this is just the sine curve. Okay, then in levels 1 and 2, we looked at, hey, what happens if there's more cycles from 0 to 2 pi? Okay, first I'm going to look for the midline first. The midline again is 0. Okay, the amplitude from the midline to the max, the amp is 1. So I'm going to put a 1 right there. And here we can clearly see the number of cycles from 0 to 2 pi. Okay, there's 1 cycle, 1 5-point pattern of the sine curve, 0 max, 0 min, 0. And then here's another cycle, 0 max, 0 min, 0. So there are 2 cycles from 0 to 2 pi. Okay, so if we wanted to simplify this thing, we would just say y equals sine 2x. Okay, but on delta math, you would enter it like this. Okay, now this tells us there's 2 cycles from 0 to 2 pi. So that was a change in frequency. Not amplitude, but frequency. Frequency, think of like an accordion. You can smash it in or pull it out, and that changes the frequency. Okay, now here's what's new. What if it's difficult to count the number of cycles from 0 to 2 pi? Okay, I'm going to start again with my midline. Notice from here, 2 pi is right here. It's hard to count the number of cycles. We don't even have 1 cycle in there from 0 to 2 pi. So I'm going to start off. I know I have a midline of this thing at 0. So that's my midline. I know I have an amp of 1 because that goes from here to here. So I have an amp of 1. And then here, the number of cycles. Okay, for levels 3 and 4, we're going to use this. The period, which is how long it takes to complete 1 cycle, the period is 2 pi over the number of cycles from 0 to 2 pi. So the period, if the number of cycles from 0 to 2 pi is just 1, then this would be 2 pi over 1, and the period would be 2 pi. And here the period is 2 pi. That's how long it takes to complete 1 cycle. Okay, but if it's hard to find, what we're going to do is this. We're going to set the period of what we're given equal to 2 pi over something. Okay, we need a variable for this. Well, let's not call it x. Let's just call it, well, I don't know, let's just call it b, because boy, oh boy, are these fun. Okay, so what we're going to do here to find this, what we're going to do is set 2 pi over b, set that equal to the period. The period of this sine curve is 3 pi. So I'm going to make that 3 pi over 1, and then solve for b. And b is what goes right here. B, what we get for b goes right here, where b is going to be the number of cycles from 0 to 2 pi. Okay, that's what's going to go. That doesn't look like an arrow, but there we go. That's what's going to go right here. Okay, going back here then, I'm going to do the butterfly method and I'm going to solve for b. So 3 pi times b, that does not show up very well. Let's choose a different marker. And I do cross products. 3 pi times b equals 2 pi. Now I'm solving for b. So I'm going to divide by 3 pi, divide by 3 pi, so those go away. So b equals, now over here the pi's cancel and you just get 2/3. Okay, that's the number that's going to go, b equals 2/3, that's the number that's going to go right here. So I'm going to put 2/3, it's hard to see, but 2/3 is what goes right there. And if we look back here, from 0 to 2 pi, we do this much of a cycle. Here's 0 to 2 pi. We do that much of a cycle. So it sure looks like we do 2/3 of a cycle from 0 to 2 pi, and we do 2/3. So this graph would be y equals sine 2/3 x. Okay, so that's what we're going to do today. Now I'm going to run through a few more of these with you so we really get it down pat. But this is what we're going to do. You're going to take this, 2 pi over b. So what we're going to do is take 2 pi over b, set it equal to the period. And we're going to get the period by reading the graph. And reading the graph just means looking at the graph to figure out what the period is. Here I looked, it took till 3 pi to do one complete cycle, so that was the period. Okay, let's do this. You guys are doing great. All right, here we go. In fact, I'm going to lower this so we can see this a lot better. Let's just take a second to lower this. Hope you're having a good day. There we go. Okay, here we go. Actually, let's just do that. It says Trig Graph Discovery Level 3. And I'm going to refocus now. There we go. Write the equation of the trig graph. Try whole numbers or unit fractions for the value next to x. So they're telling us this number right here is going to change, just like it did back here in our example. 2/3 was what went right there next to x. Okay, the first thing I look at is the midline. That's the approach I'm going to take with this homework. So I'm going to first look and see that the midline is right there at 2. So I'm going to put a 2 in right there for the midline. The next thing I'm going to look at is the amplitude. The amplitude is from here to here. Notice it spans 2, so I have an amp of 1. So I'm going to put the 1 in right there. Now I'm going to look to see what the period of this thing is. One complete cycle. Now we're looking at a sine curve. So my 5-point pattern is going to be 0, max, 0, min, 0. So it completes one cycle. I don't know if you can see that, but it completes one cycle at pi over 2. So what I'm going to do is I'm going to set 2 pi over b, set it equal to pi over 2, because that's how long it takes to complete one 5-point pattern, one cycle. Okay, now I'm going to do cross products. So pi times b. Oh, you can't see that. Let's move that up. pi times b equals 4 pi. Now when I divide by pi to solve for b, I get b equals, now the pi's cancel and you just get b equals 4. So 4 is what goes right here. And if we take a look at our graph, now that we got b equals 4, that means there's 4 cycles from 0 to 2 pi. And let's just look and see. Well, 2 pi is right here. Here's 2 pi. So here's 1, 2, 3, 4. And in fact, there are 4 cycles from 0 to 2 pi. So 4 is the correct answer. Okay, we're going to do a few more of these. I really want you to get it down pat. Okay, again, we've got a sine curve. Now my midline is going to be, let's see, I'm going from 3 to negative 3. Oh, well, my midline then is just going to be right here at 0. So we have a midline of 0. We have an amp then from here to here. So we have an amp of 3. So 3 goes right here. And now let's figure out one cycle. So it's a sine curve. It starts at 0. So 0 max, 0 min, 0. So it ends right here. Okay, now that's kind of hard to see, but it actually ends at 8 pi. This right here is 8 pi. So it completes one cycle at 8 pi. So that's the period of this thing. The period of this thing is 8 pi. Okay, now we need to find b. So we're going to go 2 pi over b equals 8 pi. And I'm going to put 8 pi over 1 so I can solve for b. So now I have 8 pi times b equals 2 pi. Now I'll divide both sides by 8 pi. Those go away. B equals, okay, the pi's go away, so I get 2/8, which is 1/4. So b is 1/4. So I'm going to go back here and put in 1/4. Okay, now that makes sense. It would complete, 2 pi is right here, up here at this max. Here's 2 pi. So it only gets 1/4 of a cycle done from 0 to 2 pi. 1/4 of a cycle, this would be a half, this would be 3/4, and this would be a full. Okie dokie. Let's do a cosine graph. Okay, again, I'm going to point out that they're giving you the regular cosine graph in black, and we need to figure out the new cosine graph in pink. All right, I'm going to start with the midline. The midline is right here at 1. The amp then is from here to here. So we have an amplitude of 1. Now, let's figure out what the period is. So I'm looking at a cosine. So my cosine is max 0, which is now at my midline, max 0 min 0 or midline, and then max. So this actually completes one cycle from here to here, and that's at pi over 3. That's the period of this thing. So what I'm going to do is take 2 pi over b, set it equal to pi over 3. Okie dokie, let's just cycle through these numbers. So what we've got here is pi b equals 2 pi times 3 is 6 pi. Divide by pi, those go away. B equals, the pi's cancel, and I get b equals 6. So that's what goes back here, 6. So that's telling me there's 6 cycles from 0 to 2 pi. Let's just count them. So there's 1, 2, 3, 4, 5, 6, and there is 6 cycles. And you can't maybe see that, but it's 2 pi right there. Okay, that's that. See, now what's changing is the frequency. It's like whoosh, being pushed together. So the frequency changed there. Okay, you know what? I think we're good with this. I think we've done enough of these. I think you're getting the idea. There's another level 3. Let's look at level 4. Here we go. Here's level 4. Let's see what's different about this. First, I'm going to find my midline. Since this goes from 0 to 4, I know my midline is right here at 2. My amp from here to here is also 2. Okay, there again, it spans 4. My amp is half of that, so my amplitude is 2. Now, let's figure out the number of cycles from 0 to 2 pi. So this is a cosine curve, so it's going to start at a max, and it'll end at a max. So here's my cosine curve. So I have one period at 3 pi over 2. So the period of this thing is 3 pi over 2. So I'm going to set 2 pi over b, set it equal to the period, 3 pi over 2. Cross multiply. Divide it out. B equals, the pi's cancel, and B equals 4/3. So 4/3 goes right there. Okay, that one was not really different than level 3. Okay, next one. Well, now that's going to be similar. That's the sine curve. Okay, here's the one I want to go to. This one's different. I'll show you why. Okay, first I'm going to find my amplitude. I'm going from 0 to -4, so that means my amplitude is right here at -2. And my amplitude is 2. So that goes there. Okay, now I'm looking at a cosine curve. So I'm going, oh, this is interesting. My cosine curve starts at the minimum and ends at the minimum. So my cosine curve looks like that. Now, since it's starting at a minimum instead of a maximum, which is your typical cosine curve, that's going to change things. So that means that I'm going to have to put a negative right here. -2, because it starts at minimum. Okay, now let's look and see what the period is. Notice the period here is 20. They did not give it to us in terms of pi. The period is 20. So 20 is the period of this thing. Okay, we're going to work with it the same way. We're going to set 2 pi over b equal to 20 over 1. So 20b equals 2 pi. Now we're going to divide by 20. We're still going to solve for b. So b equals, now notice this time the pi does not cancel, but the 2 and the 20 reduces to 1 over 10. So b is actually pi over 10. I'm going to go back here, and you're going to put in pi over 10. Now notice that they have the option to pull up the key called pi right here. So when you enter this in Delta Math, you'll hit pi, and then divided by 10, and then that will pull up pi over 10 for that coefficient of x right there. Okay, now what does this mean? Let's talk about this, because this is weird. Pi over 10 cycles. What does pi over 10 cycles mean? Okay, pi, you know, is about 3.14. So 3.14 divided by 10 means, well, that's about, let's just say 3/10 of a cycle. Or approximately, that's kind of like 3/9, which is 1/3. So it's kind of like 1/3 of a cycle. That's what I would be thinking. Oh, here we go. That's what I would be thinking in my head. We get about 1/3 of a cycle done before we get to 2 pi. Now remember, that, oh, where can I go? Okay, so remember 2 pi is 6.28. Okay, here's 5, here's 10. So this would be 7.5 right about here. So 6.28 is right about here. So this is 2 pi right about here. We're saying we get about, now I'm approximating, but that's okay. So we're getting about 1/3 of a cycle done from 0 to 2 pi. And look at this. If I go from here to here, that's about 1/3 of a cycle. Right here is about 1/3 of a cycle. And then I would have 2/3, and then I would have 3/3 a full cycle. Okay, I just threw a lot of information right there at you. But I was hoping to help pi over 10 make sense to you. Okay, you can always hit pause and replay or whatever to understand this better, but this would be our final answer. Keep in mind, again, this is a -2 because we're starting at the minimum. This is pi over 10, and this is also a -2 because our midline is -2. Okay, this is probably the most challenging section that we've done in remote learning, possibly. It's hard to say, but I'm really proud of you guys for doing this. Okay, let's do one more in level 4. Okay, here we go. Here we again have a cosine curve. Oh, look, we're going from 4 to -4. So that means our midline is right here at the x-axis. So our midline is 0. Okay, now the cosine, our amplitude then is going to be 4. Okay, I didn't mean for that little smudge to be there. It's a +4 because we start at the max and we end at the max. So here we go. Here's one cycle of the cosine curve, and that ends at 12. All right, so we have a period of 12. Well, okay, I'm just thinking through. 6.28 would be about right here. This is 12, 6 would be about right here. I'm thinking I'm going to end up with about a half a cycle. That's my estimation. I'm going to estimate about a half of a cycle, but let's find it exactly. Let's set 2 pi over b equal to the period, which is 12 over 1. Okay, so we have 12b equals 2 pi. Divide by 12, divide by 12, those are gone. So b equals, now the pi does not go away in this case, but the 2 and the 12 reduces to 1 pi over 6. So b is pi over 6. I'm going to go back here and put that in. That's what goes here, pi over 6. Okay, now what does that mean? Well, let's think about it. Pi over 6 means 3.14, etc., divided by 6. Well, son of a gun. Would you look at that? That's like 3/6, which is in fact 1/2. Now keep in mind, this is all estimating because I rounded 3.14 to 3, so it's about that. And so the 1/2 a cycle was pretty darn good. We ended up with pi over 6. Okay, so that's it. I think that covers everything. I just want to look back and see at one of these that I skipped over. Was there anything unusual here? Not really. Okay, this is a sine curve. Oh, I see what's interesting about this. Yeah. You know what? Let's do this one. Okay, because this is a sine curve. Here's what's unusual about this one. Okay, now let's just see. We go from 5 to -1, so that's 6. So if I go 3 down, 1, 2, 3, there's my midline. Right there at 2. So I have a midline at 2. I have an amplitude of 3. Now, we're looking at the sine curve, and notice that if I start here at my midline, instead of going 0 max, 0 min, I'm going 0 min, 0 max. So my curve actually is in reverse. So I've got to make sure and put in a negative right here because the sign starts out going down. Okay, now let's find the period of this thing. The period ends right here at, let's see, 10 pi over, let's see what that is. Hang on just a minute. 10 pi over, gosh, it's hard to read. Oh, okay. The period ends at 10 pi over 3. That's our period. Now you'll be able to see these on Delta Graph, on Delta Math a lot better. What I did is I took a screenshot of it and then I enlarged it, so some of the numbers got kind of blurry. Okay, let's go about this the same way. 2 pi over b, set that equal to the period, 10 pi over 3. Cross multiply, 10 pi times b equals 6 pi. Let's solve for b. Divide by 10 pi, divide by 10 pi. So b equals, okay, now here the pi's cancel because our period was in terms of pi, not like back here where your period was just in terms of a number, like 20. Here our period is in terms of pi. The pi's cancel, so this is going to be 6 over 10, which reduces to 3/5. So 3/5 is what goes right there, 3/5. So that means we have 3/5 of a cycle from 0 to 2 pi. Now let's see. Here's 5 pi over 2. So 3 pi over 2. Well, they don't really have it listed here. I think. No, they don't. I don't really see it. But anyway, we're going to get 3/5 of a cycle done from 0 to 2 pi. Okay, that takes care of that. Let me see. Okay, so this one we did. Let me see if there was one that I skipped that I think we should do. No, nothing really fantastic going on there. I think that all of these that we've done explained all of them. So you can reread this. I know this was a little bit of a longer lesson, but these graphs are kind of fun and kind of challenging, and I think you guys will do great with this. Okay, so thanks everyone.